Hi, I'm Ibrahim Ethem. I'm a PhD student in Lancaster University at the School of Computing and Communications. And today I'm going to talk about our work in the department with my colleagues, which is jamming-based protection against unsolicited messages in the smart home. Home automation is a growing phenomenon these days, and everyone can have these devices. It's not limited to luxury markets. In our home automation, we have different network types. And these network types have different protocols. These network types are integrated through home automation controller. And this home automation controller has some processing logics and algorithms that defines smart home. In home network, we have TVs and smartphones, which helps to manipulate these different network types and improve the performance. Some of the duties of these home automation controller can move to cloud service, for example, storage or processing. The protocols that are used in these different network types, they don't provide any security mechanisms. So, unsolicited messages may be processed by the nodes. It can be done by accident because they have small address spaces, or it can be done by an attacker on purpose. So we need to retrofit the security. We can divide home automation protocols into two, like basic protocols and advanced protocols. Basic protocols are used in low-cost devices. They don't have any security features. And communication protocols are very simple. They are proprietary, and this helps to produce products for mass market. They are cheap. Devices can typically only receive or send, so there are no acknowledgements are possible. So the packets are repeated to make a reliable communication. And the routings are not enabled. On the other side, we have advanced protocols. They are relatively expensive, but they support basic security features. You can build multi-hop networks, and bidirectional communication is available. Mostly in home automation, basic protocols are used because they are cheap and they are available mostly. And but to improve the security, we can easily upgrade these devices with the security standards. But however, the already deployed devices, and there are lots of protocols and stakeholders involved, it's not realistic in the future to upgrade these devices. So we need another idea. Our idea is jamming unsolicited messages in the smart home. Home automation controller will identify the unsolicited message, and if it decides the message is unwanted, then it will jam it. It's like constructing a wireless firewall. But there are some challenges. For example, not all messages can be subject to jamming because some of them might be legitimate. And address recognition must be carried out before jamming. And this address information is a very tiny bit, so the recognition should be very specific. And jamming can only be applied to part of the message. You cannot continue to jam all the signals all the time. You may end up with jamming the legitimate message, and several jamming devices may be necessary as well to cover enough area. Our jamming device is based on Zolartia Z1 sensor nodes. It's shown in this picture. It has a receiver and a transmitter, which is connected to a single shared antenna. The receiver listens the medium at a full speed, and if it is realized there's an unwanted message, it sends a jamming signal through its transmitter. In these pictures, we are seeing two sample protocols, which is HomeEasy and ProTeam. HomeEasy is used in power sockets and light switches, and ProTeam protocol is used in power sockets. I'm showing these two examples because I said that protocols are different in these different network types. So for example, HomeEasy, to send a packet with HomeEasy protocol, you need to send the preamble first. but you don't need it in Proteum protocol. And representing bit 0 and bit 1 is different between these different protocols. So our jamming device should have different rules for different protocols. To jam, we need to first detect the jamming unwanted signals. So we have two different detection mechanisms. First one is modulation detection. This analyzes the timing of the first N bit of the transmission. And we have address detection, which analyzes the M bit of the address information. And we have two different jamming options. We send a carrier wave for N bits, or we jam M packets, the packet that we are going to jam, and plus M minus 1 subsequent packets. We have two different tests. First one is range test. We did this with Proteum devices. We located jammer and receiver with 1 meter and 5 meter support, and we sent 1,000 packets. We have 4-bit modulation detection, and we have 4-bit jamming. Sender and the receiver are located 2, 6, 10, 14, and 18 meters apart. As you can see, for two different distance options, we have a very small failed jam rate. Our second test is detection test. We did this with home easy devices. Our sender, receiver, and jammer are located 75 centimeters apart, and we send 5,000 packets. We jam 1 packet and 2 packets, and we have modulation detection and full address detection. As you can see, we have again a very small fail jam rate. The summary: there is no 100% protection. A single packet not intercepted may be crucial. So this mechanism should not be the only security mechanism deployed. Just like a normal firewall, it's an additional security mechanism. There may be some improvements. For example, you may use multiple jamming devices. Better detection mechanisms are definitely possible because we sent continuous signal, jamming signal, and we achieved 100% jamming success, and better jamming methods may be possible as well. Thank you very much.